Class, Assalamu alaikum. I'm by name Dr. Mahmoud Abdul Salam of the Department of Physics, Umar Musa Yar'Adua University. And I formally welcome you to PLBC Virtual Classroom. What we are going to look at is what we call the modern physics. Modern, new physics. What does this modern physics entails? And why do we study modern physics? Well, the first thing that I need to ask at this point is, we are all here. Within here we can see that we have chairs, we have human beings, we have fans. What are we made of? Is it that the composition of human being, what human being is composed of, is it similar to what fan is? What I'm trying to say is, okay, under modern physics, what we are going to start with is the atom. Yes. You know, the atom is the building block of matter. And as we are here, we are all matter. Is that true? So now that we're talking about the atom, what are the models of atom? What happened? What are the developments that give us an idea of the composition of atom? So, having mentioned the atom, earlier the first model of atom that, okay, let me say one of the most famous first model of atom is the Dalton atomic theory. What is it all about, the Dalton atomic theory? Well, during his time, we knew that, okay, matter is made of atoms. And as at the time that Dalton formulated his own theory, scientists were of the belief that the smallest form of matter, the smallest indestructible part of matter is the atom. What does it mean by this? It means if you have the atom, is the smallest piece of matter that you can have, you cannot divide it further. The atom is the smallest part you can achieve. Is that clear, please? So atom, okay, the Dalton theory, atomic theory, is saying that the smallest form of matter, the most indestructible part of the matter is the atom. And that if you have, let's say, hydrogen and oxygen, the composition of the atom in oxygen is entirely different from that of hydrogen. But notwithstanding, anywhere that you're going to see atom of hydrogen, they have some kind of similarity in terms of matter. The building block, the atomic building block for that atom is the same. However, when hydrogen and oxygen are going to come together to form water, they do that in a simple ratio. For example, you have what you call H2O. 2 hydrogen atom and 1 oxygen atom. In a simple ratio, this 2:1. Whenever they combine 2:1, they are going to form water. That's what we know about the Dalton atomic theory. Unfortunately for this atomic theory, as time goes by, we realize that, look, within this atom, there is something that we call an electron. And that this electron is smaller than the atom. So since the perception, the belief here that is the smallest indivisible part of matter is the atom. But now we have an electron. It means that there is something wrong with this atomic theory. Is that understood? And that we need to have a new atomic theory that is going to account, give us detailed explanation of how the atomic theory, we need to have just a new form of atomic theory. Is that understood? So as at this point now we understand Dalton atomic theory has failed. And we need to have a new theory that is going to explain electron as composition of the atom. As a result of that, what scientists did was they came up with what we call model. What do I mean by model? Do you know what we call hypothesis? Hypothesis. Do you know what we call perception? Okay, but if I said a testable experiment that can conform to be true or otherwise, do you understand what I mean? For example, it is believed that it's expected whenever there is cloud, we expect to see rain. Is that true? But it may not be possible that all the time when you have cloud, you can have rain. This, what we mean by a model is we are going to put forward some explanation that we are going to expose these explanations to set of experiments. We are going to subject them to tests. The test that we are going to subject them with, it will later confirm to us whether the model is correct or otherwise. For example, you are a model of yourself, of your own. As you are, the model is real. Is that okay? But it's possible, the car that we have is a model, the aeroplane is a model. And we can have a mathematical model, set of equations put together to explain some natural phenomenon. Is that okay? So whenever we have, let's say, some set of explanation that we try to use to explain something, we call it a model. Is that understood now? So after the Dalton atomic theory, what we have is we have models of atom. Why do we call them model? Because we are going to subject them to tests to verify whether what we have is correct or otherwise. The first model of atom we have so far is that of Rutherford. All right, so having realized the failure of this model, the Dalton model, now we have the Rutherford model, which has clearly explained that, okay, we have the negative charges and then the positive charges, and then the net total charge in the atom is 0. But then we are now faced with another bigger challenge. When you bring in a positive charge close to a negative charge, the two will neutralize. There is going to be a spark and they will neutralize. What this is telling us is if this is comprising of positively and negatively charged particles together, in no time the positive and the negative charges are going to neutralize and then the atom would be normal. Experimentally, if the atom would be normal, you wouldn't be here. The universe, the sun, will not be there because they are all composed of atoms. Is that understood? So it means this model too has failed, and we need to have a new model that will explain why this is not happening. Please class, are you with me? If I'm to ask you to summarize what we have said here, can you be able to do that? All right, so now with this, Rutherford has failed, and we need to establish why the failure. That's when this guy came, J.J. Thomson. What J.J. Thomson did was, he's trying to establish what is the reason for the failure. And what he did is, he has a small film of gold. Okay, before this time, actually what happened, can you remember this radioactivity? Under radioactivity, what happened is you have a piece of atom, an element. The element will start ejecting some new elements, the alpha, the beta, and the gamma. So as at that time when Rutherford wanted to do his experiment, alpha particle was discovered. And he wanted to use the alpha particle because as at that time, physicists were using that alpha particle as a bullet. They use the alpha particle to eject something, to fire it as something, and see what is going to be the behavior. So what Rutherford felt he wanted to do is, he wanted to have detailed idea on how is the structure of this atom. And he used an alpha particle to bombard this thin film of gold. Before directing it, he made sure that he surrounded this place with a kind of photographic film. And now this is his alpha particle directed toward this. Do you know what he observed? Rutherford realized that some of this alpha particle will pass through the gold undeflected. Is that understood? And he observed that some of the alpha particle will now go in this direction, hit somewhere, and then they will come back in the same direction. You understand what it means? He fired the alpha particle, it will hit him and then it will come back to where it was going. Some will just pass undeflected, and then some are deflected at an angle of 90 degrees, and some scattered in this direction. You understand the observation? Some of the alpha particle will pass undeviated. Some are fired back at an angle of 180 degrees. They go this way, they come back this way. Some are deflected at an angle of 90 degrees. All right, now let's try to analyze and see what this experiment is telling us about. What this is telling us about is, if you bring in a positive and a positive charge together, what happens? Repulsion. Is that true? So it means, okay, and part of the observation is the alpha particle, because we believe alpha is positively charged particle. Is that true? The alpha particle that is hitting the center of the atom is the one that is being deflected at an angle of 90 degrees. So if at the center of the atom, the alpha particle going there will now come back along the path it was going. Is that okay? This is giving us an information, and that information is within the center. It contains something that is reflecting back, repulsing a positive charge. And what is it that is going to repulse a positive charge? It's a positive charge. That means within the center now, the center comprises, which he calls the nucleus, comprises of the positive charge. And then it is realized that it is the same alpha particle that is moving within the center, within, close to the center, that are being reflected, deflected at an angle of 90 degrees and the rest. And those that pass within, far away from the nucleus, will now pass undeflected without the influence of any of the charge of the proton. Is that understood? So now, it's already established, for this atom to be neutral, it must have the positive charge and it must have the negative charge. Now, since the center is where the positive charge are concentrated, it's telling us that the negative charge are not somewhere within the center. Is that true? But in that case then, outside here there is going to be what we call the shell, the atomic orbitals. And it is within these atomic orbitals that we have the electrons. Please, do we have the idea here? The alpha particle going toward the center is deflected back. Close to the center is being deflected at an angle of 90 degrees and the rest. Those that are passing somewhere far away from the nucleus will not suffer any of the influence of the positive charge within the nucleus. Is that understood? So in that case, the only point within the atom where you have the positive charge is the nucleus. So that's what gives the idea to J.J. Thomson, that it is only within the nucleus that we have the positive charge. And it's already established that there are electrons within the atom. So if there are electrons within the atom, it means the electrons are not in the nucleus. Rather, they are somewhere within the shell, orbiting. What do I mean by orbiting? Going around the nucleus in the same way that the sun, the earth is going around the sun. Do you understand, please? Do you understand? All right, now, I believe this has explained the failure we observe in Rutherford. Is that okay? Because it's already established, okay, they are not close. The electron is outside and is going around the positive charge. And now, if that's the case, okay, and somehow I think that's explained the stability. Is that okay? Is that okay? But then we still have one more problem. Electron, is it charged particle? Electron, is it a charged particle? What happened? Because if the electron is orbiting, if something is going around a cycle, is it accelerating? Sorry. You see, we understand these terms, velocity and acceleration. Is that true? The velocity, we have speed, velocity. Speed is scalar, velocity is a vector. Acceleration is a function of velocity, rate of change of velocity, dvdt. As such, acceleration is a vector too. Is that true? Now, we have this going around nucleus. Is it, can we say that it's accelerated? What do we mean by accelerated? I'm still trying to go back to the basic of the basic of the physics so that we appreciate what we are seeing. If we said something, okay, what do we mean if we say something is accelerating? If we said a particle is accelerating, what are we trying to say? You can't remember. You can't remember. All right, so please let me try to remind you. For example, let's say we are having velocity time graph, something like this. At this point, the velocity is increasing. Is that true? If the velocity is increasing uniformly, we said that the particle, okay, we have uniform acceleration. Is that true? The velocity is increasing. As such, it's accelerating. You are trying to ride your motorcycle. You're trying to ride your car. By the time you press in the accelerator, you find out that the tachometer, the accelerator there will be indicating and it will be increasing. As such, the velocity is increasing with increasing time. Is that true? And that's the point you are recording here, and that's the point where we say is accelerating. Because by what we mean by accelerating is the velocity is changing with respect to time. Do we understand? If the velocity is changing with respect to time, we say that such a particle is accelerating. Now, in this case, is the velocity changing? Okay, let's assume is moving at 25 kilometers per hour. Just an assumption. Going around everywhere is moving at 2 kilometers per hour. Can we say that this particle is accelerating? Attention please. Are you with us? Oh, you are tired. Are you tired? Then sit properly. It's going around, right? Can we say it's accelerating? Okay, I think, okay, let me explain to you this. Even if it's moving at 2 kilometers everywhere, like this point, you see the velocity is not changing. Is that true? And radiating energy until when it will get to a time where the energy of the electron will eventually finish. Please, do you understand what we are saying? What we are saying is like this guy, now that you have eaten food, right? You are full of energy. If I'm to ask you to start going around this chair, there is going to be a time when even if you keep going, all the energy in your body is going to be exhausted and you cannot continue anymore. Is that true? So by law of, by the laws that we have of electromagnetism, It means if it's going round and round and round, it will start radiating energy. If it's emitting light, radiating energy. By radiating energy, it means it's going to reach a point when all the electron is going to release its energy, and it will eventually collapse. Do you understand this? And as far as we are concerned, in reality, we have never seen a situation where this happened. Are you with me? And if it has never happened, it's telling us that's not the case. It's not happening. This model, the Rutherford, the Thomson model, successfully explained to us that it is the center that comprises the positive charge. It successfully informed us that we have electrons orbiting the nucleus. But it failed to explain the stability in the atom in the same way that Rutherford failed to explain the stability of the atom. If the atom is not stable, it means nothing is going to exist in the universe. And yet, we have flower, we have the sun, the light, you and I are here. And it means that that's not what is happening. Is that understood? So to have successful, clear explanation of the atomic model, it means we have to go beyond this. As I said, okay, let's understand this. You know, when I wrote this model, I said that it is a testable experimental, testable information. Some ideas that we have, that we are going to subject them to test, to experiment and see if they are going to fit. Is that true? So now we have started with atomic, the Dalton field. We moved to Rutherford. The Rutherford field, we moved to Thomson. And now the Thomson model too has failed. We need to have a new model that is going to be successful. Is that understood? In this development, you can see that we have started from this moving to this moving to this. That's the reason why it is under modern physics. And now we are going to fully into the new physics. What is it telling us? Okay, let me ask us something that we are all aware of. If I ask you to write electronic configuration of, let's say, oxygen, how are you going to write it? Electronic configuration. Sorry? It's still within chemistry. Electronic configuration, can you remember it? None of you? Please, voice it, don't be shy. Voice it out. If you have an idea, say something. None of you can remember. Can you remember the 288 orbital electronic configuration? 288. If you can remember that, what about the SPDF? 1s2, 2s2, 2p6. Can you remember them, please? Can you? Okay, which one can you remember? Which one can you remember? Is it the 288 or the SPDF? The 288. Okay, it's fine. You see, when we write, let's say 288, it means we have an atom. In here, this is the positive charge. In here, we have 2 electrons. Within the next orbit, we are going to have 8 electrons. Within the next, we are going to have 8. That what we mean by 288. We are now writing the subatomic levels. Is that correct? Is that correct? So now, with the failure of J.J. Thomson, we need to have a new model that will explain the atomic behavior of the atom. And in doing that, we have what we call the Nil-Bohr model of atom. What did he say? When he came, he looked at the Thomson. He tried to identify the reason for the failure in the Thomson model. And in it, what Thomson failed to account for is the fact that this is going round. And he said that it should be emitting energy, emitting light, radiating. Is that true? But then, what this guy is trying to, what this guy said is true. The electron is moving, is orbiting. But electron can only emit energy if it jumps from one energy level to another. Because look, this is one energy level, this is another energy level. You don't expect the energy of this to be similar to the energy of this. Is that okay? Do you understand what we are saying? Okay, let me try and talk to you in a layman's language. Electrons can only emit or absorb energy if it moves from one energy level to another. You understand what it means? For example, okay, how do I explain? Maybe the energy of this is 2 electron volts. The energy of this is 8 electron volt. Example, we can see that the energy of this is higher than the energy of this. It means for electron to move from this orbit to this orbit, it needs to absorb additional energy so that it can have up to 8 eV. And if it's moving from this to this, it means it needs to let go about 6 electron volts. Is that understood? And this is the only point where the electron do emit or absorb energy. So with this, we have a model of atom that clearly explains the structure of the atom, the time at which the atom is going to absorb or emit energy. For example, you can see that we have lights here. The light is as a result of emitting energy from atom. And this is in line with what we have here. Is that understood? So whenever the electrons are charged from lower, they are charged, they absorb energy and then they move to higher level. From higher level, they release energy and then move down to lower level. And this, to some extent, give us an idea of how the atom is. Is that okay? And apart from this, and this is what took it to modern physics, because this is what brings about what we call photon of energy. What this is telling us is if an electron is going to move from this energy level to this energy level, it needs additional 6 eV. Is that okay? If you are going to supply it with an energy of, let's say, 5.9 electron volt, you see it's not going to be sufficient for it to be here. It will not absorb the energy. But if you supply it with exactly 6, it will now move to this. It either absorb a whole required energy to move to the next level, or it will not absorb anything. Is that understood? So far, these are the models of atom that we need to understand at this level. Yeah, I think at this point it's good if I can ask, okay, is there anything that is not clear that you want me to clarify? Okay. In the J.J. Thomson, what we said he did is, okay, he fired alpha particle, which is positively charged, on the nucleus of gold. Is that okay? This is positive, right? Within the center here is positive. So if positive is coming across positive, what happened? It deflects back. Do you understand? And he observed that within the center is deflected. Those that are coming close to the center are being deflected at different angle. You understand? And this confirmed to him that it is the center that comprises of the positively charged particle. And if the charged particle are only concentrated only in the center, it means the electrons cannot be found at the center. All right, right? Rather, the electrons are outside somewhere orbiting the center. And that's the Thomson model of atom. Did I explain? Yeah, did I answer your question? Is there any other question? Wake her up, please. So if you don't have question, can I ask my question? Can I ask my question? What is the difference between Bohr model of atom and that of Thomson? I can't hear you. What are the difference? Because if you cannot state the difference, it means you do not understand the two. What are the difference between the two? Okay, the issue is, let me explain here is, this one is saying that the electrons are just going around. And if they are going around, they should be emitting energy. But this one, when he came, he confirmed that yes, they are going around. But they only emit or absorb energy when they are moving from one level to another. Is that understood? We have different atomic levels. It is only when it's moving from one level to another that is absorb or emit energy. Is that understood? Is that understood? So, I think if this is all clear, can we move to the next topic of discussion?